For example 3, I need to talk about a couple of things. One is that if I have a circle, and we'll call the circle O, and then we'll have a point of tangency at P. The reason it's called tangent line, in other words, P is the point of tangency. But one thing that we know is that it's called a point of tangency. You can really only have a tangent line and a point of tangency. But basically, tangent lines are perpendicular to the radius. So this radius OP is always going to be perpendicular to a tangent line. The only way you can get this 90-degree angle, in other words, a line can only intersect a circle at one point if it is perpendicular to the radius. Another thing that I want to talk about before we jump into problem number 2 is that if you have a circle and you have a point of tangency here and a point of tangency here, and they have a common point, then they are congruent. In other words, if I have a common point S, then RS is congruent to TS. Okay, so we're going to say that this and this is congruent. Actually, we don't even need to draw the line. We're just going to focus on the segment. I don't want to confuse you guys. Okay, so this is done in such a way that this is a 90-degree angle with this, and this is a 90-degree angle with this. That's the only way you can get a tangent line. But the main point that I want to make here is that these are congruent. So the reason I say that is I want to give you an example. Example 3 and example 4 are applications of these two concepts. So for example number 3, I have a circle P, and P intersects T here, and it goes all the way out here to S, and then we're told, or we're asked, is the line segment ST tangent to the circle P? So now when they ask a question like that, oh, and they give us some information. This is 35, from here to here is 37, and from here to here is 12. What they really want to know is this line segment, so that's the question they're asking, and we need to think, is triangle STP a right triangle and then also is the measure of angle STP equal to 90 degrees. Now one way we can identify that is that we would have to do the Pythagorean theorem. So I have all three lengths, so if the Pythagorean theorem holds true, then In other words, if I plug in these numbers and the left-hand side equals the right-hand side, then yeah, this angle would be 90 degrees. So I have to identify what the hypotenuse is. In other words, I'm checking to see if this is 90 degrees, so the hypotenuse would be 37. So this would be like lowercase c, this could be A, and this could be B. Now A and B don't really matter, it's C. We always got to label C properly. Okay? Now they did this on purpose. If you look at the image, this almost looks like it could be 90 degrees as well. Okay? So we got to check that. So I'm going to say 12 squared plus 35 squared should be equal to 37 squared. Probably not, because that's, I don't know, we'll see. So I'm going to take my calculator and I'm going to say 12 squared plus 35 squared and see what that equals. 1369. I said probably not, but maybe it is. I don't know. I'm curious now. And then I'm going to see if that's equal to 37 squared. So I'm going to say 37 squared. Oh, hey, look at that. 1369. So if this is 1369 and this equals 1369, then yes, the measure of angle STP equals 90. So ST is a tangent of circle P.